Okay, so we are Team 13 and I'm Sindhu. Our project topic is Twitter, summing up the pulse of the internet. So the main aim of our project is to build an ETL pipeline to extract Twitter data and move it to our destination database, where we perform some analysis and visualizations on the data. So first, let's take a look at our data architecture. Vatsal, can you navigate to our data architecture, please? Yeah, so this is our data architecture, and we are creating CSV files from the data that we extract from Twitter using the Tweepy API. So we are using Tweepy API to extract data from Twitter, and we're going to create CSV files from that. And we perform a little bit of cleaning using Python, and we then upload it onto Azure Blob Storage, from where we move the data to our destination databases. And all this happens in the Azure Data Factory. And we then use, we're then using Power BI to perform visualizations. Next slide, please. And this is our ER diagram. So you can see that we've included 3 different types of data models. That is the document data model, relational data model, and the graph data model. So the document data model is the hashtags data. That is the first table on top. And our relational data model includes our SQL data tables, that is Twitter header, Twitter user, and reference tweet tables and such. And so our reference tweet table is basically a table that has information like parent tweets and child tweets. And our graph data model maps hashtag data to tweet location, and tweet location is a part of the Twitter header table. So yeah, this is about our ER diagram. Next, Neeraj is going to give us more detail about how our data pipeline works.
Yeah, thanks, Sindhu. So let's check how we ran the ETL and the data factory pipeline and all the steps involved in detail. So our data source is basically generated by a Python script. So this script, it scraps live Twitter data using the Tweepy API. And we've done our authentication for Twitter and for Azure in this script itself. And we have also done some pre-processing and data cleaning before, saving our CSV and JSON files. We are saving our CSV and JSON files onto the Azure Blob Storage. So in the Azure Data Factory, which is where we create our pipeline, this is step 1. So step 1 is to run the Python script. So to run the Python script on cloud, we need to create an Azure batch pool. So this is basically a very small VM that runs our Python script, and this generates our files. So these nodes or pools, they're actually small VMs that have pre-installed Python libraries. And at the end of this first ADF operation, we'll have our CSV and JSON files for loading in the storage container. Next one, sir. Yeah. So this is how our blob container will look like after the first step in the ADF is performed. This is all our CSV and JSON files, which is basically our source data. So step 2, now that we've got our data, we have to copy this data from the source to the destination or sink, which is Cosmos DB and SQL database. Before the copy operation is performed, we'll execute a stored proc to archive and clean the SQL data before each pipeline run. So this is done to make sure that the data refresh for all our downstream systems are performed with new data, and old data won't mess with our visualization and analytics. Next, yeah. So now that we have our data in the destination, our next step is to clean the data that is generated at the source. So we fetch all the CSVs and JSONs from the container, and we run delete scripts to remove this data because we need new data with each pipeline run. We also made sure that all activities are logged so that in case we come across any errors, we can pinpoint to where exactly the operation errored out. Next. So this is how we're scheduling the data factory pipeline. We've created a trigger to run our pipeline at regular intervals. Here you can see that it's going to reoccur every 1 hour. So every 1 hour, a data is going to refresh and we'll have new analytics and new visualizations generated. So for maintenance, you can see that we can monitor the trigger runs and the pipeline runs, and we can also check logs for any errors that have come up during the run. So this is how our destination data looks like. So the SQL database has our main RDBMS tables and also the graph nodes and edges. And our Cosmos DB has the hashtags data JSON items. Vatsal is going to take up the visualization part of our presentation.
Hi. So in visualizations, first I will cover the objective and scope of our project. So our main objectives are location-based analysis, user based on Twitter for each year, analyze the number of retweets, and correlation metrics for most followed user. So we have defined these objectives by visualizing them. So here we can see most retweet count, user base per year, tweets from all over the world, most followed user, and hashtag used at locations. So we have also kept a future scope in our project. So the future scope of our project would include optimizing Azure SQL database cost and environment cost to ensure better cost management. Also building a BI dashboard for data representation and to handle archive data better. Yeah, thank you. We'll now move forward with a demo of our project.
Moving towards the demo and the pipeline, which we have built on the Azure data factory. So this is the pipeline where we gonna start the pipeline initially starts with running the Python script. So we created a batch pool having some nodes on it, VMs, which runs our Python script initially. So our Python script, as per told by like Neeraj, so it initially fetches the data from using the API TWP, and then we store the data into a CSV files as shown over here, like ETL Twitter header, ETL Twitter user, and so on. Then these all the ETLs, CSV are being copied into the relational database and the Cosmos DB for document. So the whole trigger, whole pipeline works once is run. We have also put the trigger which runs every 1 hour. And after the CSV files have been copied into the destination database, we then clear the CSV files from the blob storage where the CSV files are being kept and been stored for initial purpose. After the clearing and maintenance, we do archive the past data into the DB, and also then we use the database data for visualization purpose. So this was the Azure Data Factory view. Can we go towards the tweet blob storage? So here we store all our CSV file initially, which are being transferred into the database. The Cosmos DB next tab. Here is our document model for hashtags data. And we have a Python pool like which contains our Python script to be run within the data pipeline. That's all. Thank you. Any questions?
Hi. So,
Hello.
I have a question regarding your authentication in your Python script. How have you done that? Can you please explain?
Sure. So we have a Twitter development account. So we had to request access to that and gain access to the Twitter API. We've taken the authentication keys from that account, and we've stored it in our Python script. So that kind of covers our TWP authentication. And for the
Okay.
Azure authentication on our Python script, so you know that each storage account has a connection string, right? Which has some keys that we can use for authentication. So we've
Yeah.
just stored that in our, we've masked that and stored that in our Python script so that we can use it to push data to the blob.
Yeah,
So
sure.
that's how
Okay.
we've covered the authentication. Yeah.